Hello guys, or should I say bonjour mes amis, as we're in France. I'm going to release another build video. I've still got some footage left over from the installation of all the work that we did in the Sprinter. So I've put together a little video on the controls installation in the back of the garage and where I fitted the control panel that I made earlier on in the build. And I've also put in all of the batteries, the solar charge controller and everything else. So there's quite a lot to go through in this build, so I'm going to break it into two parts. This first part is just going to be the installation work, so I'm not really going to go into too many details about the wiring schematic and the cable sizing and so forth. I'm going to leave that for another video. So there will be a detailed wiring diagram, and I will go through with you the cable sizing and the fuse sizing and everything else in the next video, and I will issue a free schematic with that video. So make sure you're subscribed, because you don't want to miss that one. This video is just going to be me doing the installation in the back of the garage. I'm in the back of the van here and we're sorting out this rat's nest of cables that we pulled into the garage. I've just got this last piece of ply to put on the lining here, and this is where the control panel's going. So I'm just making sure that I've got all the cables in the right place before I button up this last sheet of ply. Now I've got my suspicions that I think a couple of these got labelled up incorrectly. When we were pulling through the last of these blue cables, this one here has been labelled up as living room sockets. But I've got a funny feeling that this actually goes to the toilet and is the power supply for the electric flush on the toilet. So there's one way that I can check this. I've just stripped these cables and just joined these two together, and then at the other end with my electrical tester we're just going to do a continuity test. Now I know that the other cable somewhere there, which is the cable for the sockets, both the ends are still cut and they're not joined, so that'll give me an open circuit and this will give me a closed circuit. So whichever one tests continuity at the other end, I know that's this cable. Let's jump in the front of the van. Okay, so here we are in the front of the van. Now that cable either goes to the sockets here or it goes to the toilet. Now if I test the sockets with, I've got my little electrical tester, this will tell me whether there's voltage there or it will give me a continuity check. If I put those probes onto there, no, I've got nothing there. Now if I just check this toilet cable in the same manner, yeah, you can see I've got continuity there. So that's definitely that cable that I've joined together at the other end of the van is this feed for the toilet. So that label was wrong, so it's just as well we check that, because this is 12 volt and this is 230 volt. So it would have been a bit of a problem if I'd have put 230 volt onto my toilet. So now I've relabelled that cable as the toilet. That's the one that we tested just now. And I've just taken those cables apart. So I've made that open circuit. And then the other cable that I had my doubts about, which now should be that socket, I've just joined those two cables together now. So that one should have continuity on it. So let's jump back in the front and just check those two again, just to make sure. Okay, let's just test the toilet cable. This one should be open circuit. So I should have nothing on there now. No, not getting anything off of that cable now. But if I come to the socket, this is the one that we've now joined. I should have continuity here. Yeah, there we go. So that's it. It's a good way of testing your cables if you've just pulled them through and you can't remember which is which. You can do this with a little multimeter or this little electrical tester that I've got here. And normally has a continuity test on a multimeter as well. So one or the other and you can check. The other way of doing it, of course, is you could put maybe a little small battery onto it and then you could maybe test it with a light bulb or something like that if you haven't got a multimeter. So what I've done now is I've just sorted out all the 12 volt cables. You can see they all go into the top of the panel. So I've just brought some of the ones up from the floor and through from the wheel arch there, brought them through to that top area. There were some already brought down from above into that top area. So I've just drilled a series of holes in this stud work The whole idea of this stud work was just to give me a cable way, just to get services concealed, and then when I ply over it, you won't see any of that in the garage. It'll all be hidden behind there. So they're all the 12 volts. Now all we need to do is drill a series of holes in this bottom piece of stud here for all of these 230 volt cables, because all of those go into the bottom of the panel. So there we go, that's all the 12 volt circuits at the top there. They'll all go into the top of the panel. And then that's all the 230 volt circuits. They'll go into the bottom of the panel, and they'll all just go into that terminal strip. And then what I'll do now is I'll mount the panel on the plywood, and then hopefully I can just drill through the back of the panel and through the plywood, and all these cables will come into the panel, and you won't see anything inside the van once it's all finished. I've taken photographs of these cables and their locations. I'm not going to screw into these when I fix the ply, and it will just help for future reference. I've got all the cables fed through the stud work in the back of the garage. Now what I'm doing is I'm cutting the last ply panel to go in the back of the garage. I've cut an opening for the gas connection. This board's the other way around, I'm marking it on the back. I've scribed around the rear door post and the rear door brackets, and then also what I've just done here on the back of the panel, so I don't want any cables on show, so I've cut some slots in the back of the panel here, so all the 12 volt circuits will go out of there, and all the 230 volt circuits will come out the bottom. And then I've also cut corresponding slots in my ply panel, so I can pull the cables through those slots into the back of the panel and then terminate them, and then nothing will be on show and it will be nice and clean and tidy. Then lastly, what I want to do is I want to put a double socket in this ply lining, which is directly fed off of the hookup via the isolator in here. I'm going to run a 230 volt cable out to this double socket, so when we're on a hookup on a campsite, I've got a 230 volt socket in the back of the garage, which will be quite handy. To secure the control panel to the ply lining in the garage, I'm using these T-nuts. What they are is like a pronged nut. These are M8, you can get them in different sizes, and the thread inside there will accept a bolt. And then these prongs pull up into the wood from behind. I'll flip the board over and I'll show you what they look like from the back. There, you can see they've actually been pulled into the wood. So those prongs there, you can see really sharp points. They've actually been driven into the wood. So that's effectively given me a captive nut now on the back. That won't move. And then I can wind the bolts in from the front. So now I can screw this ply board into position. And then once I'm happy, pull all the cables through, fix it, and then I can bolt my panel onto that captive nut with these M8 bolts, and that's going to give me a really secure fastening for the panel. And then at a future date, if I did want to remove it, all I've got to do is undo the bolts. If you want to use some of these T-nuts yourself on one of your projects, I'll put a link in the description below where you can purchase them. There we go guys, that's the panel mounted to the ply board. That little transformer over there is for the shower extract. It's a 230 to 12 volt AC transformer. So that just takes the feed to the shower extract and puts it down to 12 volts, so it's safe for the shower use. And then we've got all the 12 volt circuits coming through the top of the panel there. They'll go onto those 12 volt terminals. I've just got to strip those back and terminate them now. And then there are all the mains, all the 230 volt circuits coming through the bottom now. And they've just got to go onto that terminal strip there. So now it's just a case of just stripping all these cables back and then terminating them in those terminals and these terminals. That's all the 12 volt DC supplies terminated at the top of the panel. All these outgoing terminals on the positive side are connected to these individual blade fuses. So each outgoing circuit has got its own corresponding fuse. All the negatives come back and are connected to this negative buzz bar, and then the negative is wired down to these positive and negative battery terminals. And then all I've got to do now is bring a nice big fat cable from the batteries into these two terminals here, and that will feed all the 12 volt side. And then on the mains side I've got the incoming mains coming in here, I've got the supply from the inverter coming in here. They then go to that changeover switch on the door, and then they come back and into this set of trips. And then these trips then feed these outgoing terminals. And then I've got all the individual live supplies going out here on this side, and then I've got a common set of neutrals coming back. And then all I remain to do now is just get a earth terminal block and put all of these earth cables into one block, and I'll just screw that into the bottom of the panel. So there we go, that's the earth bar tucked away in the back of the panel there. I've just screwed that to the plastic backboard, so that's out of the way. One of the last things to do is to put all the blade fuses in the blade fuse holder for all the 12 volt circuits. So what I've done on this bit of paper is I've just listed out all of the devices that are connected to the 12 volt system. I'll put their running amps down there and also their recommended fuse ratings. And then just to help me, I've put the colour of the fuse carrier in that last column. And then I have got a bag of spare fuses which I'll keep in the panel. They're very cheap. I think I had 100 assorted fuses for about £2, and I'll keep them in there just in case one goes. This is our mains battery charger, which we're going to use when we're on a hookup if we need to charge the batteries. When we were doing the power installation, I put this socket underneath our control panel, and that socket is connected directly to the hookup supply. So that socket is only live when we're on hookup. This battery charger is from Portable Power Technology. They do a lot of different devices as well as solar charge controllers, battery to battery chargers. This is a 30 amp battery charger, and it's a multi-stage charger. And it's got a number of different profiles depending on what type of battery you're going to connect it to. We've got AGM batteries, which basically is a lead storage battery, so we're going to be charging on mode 1. I'm just going to plug it in on this short flex into that socket, and then we'll connect the other leads to our battery string. It does also come with an LCD remote controller. We've run the cable route through to the front of the van, and that controller is fitted on that little control panel above the kitchen in the kitchen cupboards. Just going to show you how to crimp one of these lugs onto this battery cable. These lugs come in different sizes. The cable size is 16mm, so this is a 16mm crimp, and it's got a 10mm hole in it, because I know the isolator that we're connecting onto has got a 10mm stud. Some of the other battery connections might be 8mm, so you'd want a 16x8. First thing to do is just cut off enough of the insulation so that the wire's inserted fully into the fitting. So just run a knife around the insulation, not too much, you don't want to cut any of the internal threads. Just peel that off. Now this is the tricky bit, because you need to get all of these wires inside. You don't want any loose straggling ones on the outside. So just squeeze them all together, and then it's fluted a little bit at the end, so it does help you. So just sort of just make sure that we haven't got any loose ones. They're all inside there, and then push it right home so there's no bare wires showing, and then we can get a crimp on there. This is our crimp tool. This particular one has got different teeth for different size crimps. So spin it around until you've got the 16mm one showing. Put the crimp in. Oh, it's a bit fiddly trying to do it yourself. And then just squeeze. And there you can see it's put like a hexagonal crimp on there, and that's nice and tight. What I like to do is I just like to put another one on these, because these are quite long, these crimps, so I like to put another one on the top. There we go, that's got two on there, so that's really secure now. And then lastly, just want to put a little bit of heat shrink over this. There we go. So all the bare metal and wires and that are all concealed. That's nice and secure on there. Okay guys, let me explain what we've got here underneath the garage. This is the electrical system, complete and operational. These are my three 110 amp hour AGM batteries. They're wired in parallel, so that means I've got 330 amp hours at 12 volts. Storage capacity. That's the panel that obviously we made at the beginning of the build. There's a build video for that which gives you all the internal details. You can see the green lights on, indicating that we've got 230 volt power supply being fed by the inverter. That's my 2000 watt inverter, so a 2 kilowatt inverter. Obviously that's fed off of the batteries. There is a 200 amp breaker there, just feeding the back of the inverter, and then that blue lead coming off the front goes directly into the panel, and then that feeds all the 230 volt supplies in the van. Just in the middle here, on the top there, that Expel air box is a transformer for the toilet extract fan. That's 12 volts AC and not 12 volts DC, so we've had to put a little transformer in there. Next to that is the isolator for the solar array. So that's a DC double pole isolator, so that isolates both the positive and the negative coming down from the solar panels on the roof before it goes into the solar charge controller. So that means I can just turn that switch there and kill the feed coming down from the solar panels into the charge controller. And then we have an EP-ever or Photonic Universe branded Tracer MPPT solar charge controller. This is a 40 amp charge controller, and this is taking the feed from the solar array upstairs from our 480 watts of solar, and then this is then via those thick 16mm red and black cables. In turn is then recharging the battery string. And then I have got another 50 amp breaker here, which is on that positive supply to the batteries. That is acting as the fuse and isolator for the supply to the batteries from the charge controller. That is what is charging the batteries. I've got some terminal covers to put on these batteries, so don't be alarmed that these terminals are currently bare, although the system is still live. I've got some PVC covers to put over those to make those nice and safe. And then what we've done is we've built a timber frame which is screwed into the floor of the garage, and then I've got these nylon ratchet straps tying those batteries down, so they're really secure. You know, they don't move at all, they're not going anywhere. The inverter's a 2000 watt inverter. I've also got a remote switch which is into the cab, so I can turn the inverter on and off remotely from the living space. We've also got a liquid crystal display remote controller for the charge controller for the solar system. That's in the cab as well. And then tucked behind the batteries here down at low level is our portable power technology mains battery charger, and that's plugged into our hookup power supply. That socket down there is connected directly to the hookup on the side of the van, so when we are on hookup I can turn that battery charger on if I need to, and I can charge these 3 batteries off of the mains power, shore power. There is also a remote controller for that mains battery charger. Again, that's in the living space in the cupboard in the kitchen. Let's have a look at the cupboard in the kitchen and see what we've got in terms of controls there. Right guys, here's the control panel in the kitchen area of our living space. Let me just quickly run through what we've got here. So up the top here is the switch for the gas solenoid valve. That turns the gas off remotely in the gas bottle at the back. This LCD controller is the remote controller for the mains battery charger. Here we've got the level device for the water tanks, and if we press the button we can see that we've got sort of 2/3 of our freshwater tank is full, and this little red light on here would illuminate if the grey white water tank was full. And then down here we've got the Truma controller for the boiler, which we'll run through in a separate video, and next to that is the solar charge controller. And then at the moment you can see we've got sort of 60 volts just under, and just over an amp. It's late in the day today. We can see what's actually going into the batteries in terms of voltage and amps. And then if you did have any load connected directly to the solar charge controller, you could see what you were drawing out of the system on the load side here. So that's the installation of our control panel and the batteries complete in the back of our van. If you're interested in purchasing any of the items that you've seen in this video, I'll put all the details in the description below. There'll be links there for all the pieces of equipment that I've used, whether they be materials or tools. So if you're looking for something that you've seen in the video, you'll find it in the description. I hope you found that video to be useful to you. Please do give the video a thumbs up, make sure that you're subscribed and hit the notification bell. If you've got any questions, please leave them in the comments section below and I'll come back to you as soon as I can. Cheers!